Greetings, everybody, wherever you may be, and welcome once again to French Guiana, the home of the Ariane family, for this evening's launch of Vega. Vega, the newest member of Europe's launch family, tonight making her second flight from the spaceport. Glad to have you with us for the event. Joshua Jempel here with Enrico Possamay. Enrico from ESA, he's based in Kourou, and systems manager on CNES CSG facilities. Enrico, small satellites, but a big mission tonight.
Good evening, Joshua. Yes, definitely a great day for the second launch of Vega. Let me give a great benvenuto to all the Italian community who is watching us.
You saw the green status panels on the left, signaling all is fine on board, and the countdown is proceeding normally. Take a look at the launch vehicle. Vega has 4 stages using both solid and liquid propellant. The first 3 stages run on solids and the 4th on a liquid propellant system. The 4th stage is also reignitable, very important, and we'll see that in action later on. We'll be describing each stage in turn as it's functioning.
Yes, Vega is specifically designed to launch light mini and micro satellites. It is complementary to Ariane 5 and Soyuz, which lift off heavier payloads. The 4 stages are stacked on top of each other on the launch pad and then checked under the mobile gantry. The payload composite is mounted atop the vehicle about 7 days before launch. Since then, the 4th stage has been fueled and now Vega is ready for liftoff.
Over 1,000 people from 40 European countries and industries have worked on development of the Vega launcher. It's an interesting story. We'll have time to share some of it with you later on. But for now, a first look at the passengers.
Yes, the upper passenger under the fairing is proba V. The V stands for vegetation because the satellite maps the land cover and the vegetation growth on Earth. This is built by a Belgian firm, Kinetic Space.
VinRedSat-1, Vietnam's natural resources, environment, and disaster monitoring satellite, built by Astrium for Vietnam's Academy of Sciences and Technology. VinRedSat, an Earth observation satellite, and the first commercial payload to be launched by Vega. And the final passenger, EstCube-1, designed and built by students at the University of Tartu in Estonia, under supervision of the Estonian National Space Office, the nation's first satellite. It'll measure electric forces for use on solar sails. We're going to see again the green status panels. What they are is a green, red, go, no-go summary of everything it takes to launch. All is green, so we are in business.
It indicates the status of the mean necessary for the mission. It's for the launcher, for example, its ground facilities, the safeguard, the weather forecast, and the satellites. When it's green, everything is fine, but when it's red, the countdown is stopped, and we aren't able to launch.
More in a moment. But for now, the latest news from Arianespace, the first of 2 parts. We'll be back with the mission in a moment. On April 3rd, the French government named Jean-Yves Le Gall president of CNES, France's national space agency. During the 12 years of his presidency at Arianespace, Ariane 5 launched successfully 54 straight times, and Soyuz and Vega began to fly from French Guiana. On April 22nd, the Arianespace Board of Directors praised the number of launches carried out in 2012, as well as the number of contracts signed. 2012 turnover was 1.3 billion euros and profit 1.7 million. The board named Stéphane Israël the new chairman and CEO of Arianespace. Change at the top at Arianespace. Jean-Yves Le Gall taken over direction of CNES after 12 eventful years at the head of Arianespace, where lots happened, including development of Vega. Moving into the #1 spot at Arianespace, Stéphane Israël, from whom we'll be hearing in just a moment. But before we do, what's the most important thing that you think people should know about Vega?
I think people should be aware that Vega development represents not only a technical challenge, but also a human one. A new industrial organization has been implemented with 2 Italian prime contractors who acquired a launch system development knowledge. Their people came over the ocean here in Kourou to build a launch pad, and here at the European Spaceport there are more and more Europeans. As promised, over to the new man at Arianespace now, Stéphane Israël.
Welcome to the Guyana Space Center, Europe's spaceport, for this launch of Vega. Tonight's launch is an important event.
First for me, because I'm beginning my new position as Chairman and CEO of Arianespace. I'd like to start by saluting my predecessor, Jean-Yves Le Gall, who for over a decade has led this company to the great successes we all know. It's also an important event since Vega is the third launcher operated by Arianespace after Ariane and Soyuz. This launcher takes satellites to low Earth orbit and is particularly well suited to scientific and Earth observation missions. I'd also like to especially thank our customers for tonight's launch. These are missions dedicated to the environment and to sustainable development. ESA is our customer for Proba V, Astrium is our client for VinRedSat-1 in a partnership with Vietnam, and Estonia is our customer for S-Cube-1, which marks the entry of that nation into the ranks of the Global Space Club. I'd also like to thank the space agencies with whom we work, ESA, the European Space Agency, CNES, the French Space Agency, and the Italian Space Agency, ASI. I'd equally like to thank all the men and women who have worked so hard to make this mission possible, for their efforts here at the Space Base, and for their months and years of dedication to the design and development of the Vega launcher. Nothing would be possible without them, and I offer them all my heartfelt thanks and appreciation for their work so well done. To our customers, let me say again that Arianespace will always be with them, bringing the best possible service when they need it, meeting all their needs. Now, let's watch the second launch of Vega from the Guyana Space Center. Enjoy the flight.
Stefan Israel, 42 years old, married, 3 children, trained as a lawyer initially, working in the aeronautics industry since 2007, including here at Astrium. He's down there in what we call the Flight Directorate. This is Arianespace High Command. With him, Louis Laurent, who's the Senior VP for Programs, and Edward Perez, the living technical memory of Arianespace, the top technical officer. And with them, Patrick Loire, head of the Arianespace facilities here in Kourou. Should anything unexpected arise during the mission, these gentlemen will decide what to do about it. You'll see them on the phones. We're coming to you live, as always, from the Jupiter Mission Control Center, the heart and nerve center of the Space Base.
In the next film, my boss, ESA Director General Jean-Jacques Dordain, will give us a rundown on everything that will be part of this mission.
Alors ce soir, nous réunissons 4 événements importants pour l'ESA.
Tonight we have in one launch 4 important events for ESA. First important event is the second launch for Vega, but it is not the repetition of the first flight, which was a great success last year. There are new elements on board, both a new flight program and a new system for multi-payload launches. It is also the first of a series of 5 promotional launches, and then this is the first Vega launch where operations have been transferred to Arianespace. Second important event is the presence on board of the ESA satellite Proba V, which not only has technological innovations, but also an instrument for operational service. The Proba family, which is now well underway under the leadership of Belgian industry, is a series that has allowed us, after 2 launches, to demonstrate that we could be at the same time bold on technology with perfect reliability, since these satellites are still operational well beyond all expectations. What's new is that this time there is on board an operational instrument, vegetation, to monitor vegetation evolution across the planet. Third event, the presence of an Estonian satellite. It's the first satellite in space for this country. It highlights cooperation between ESA and Estonia. The fourth event, the presence of a commercial satellite for Vietnam, marking the start of Vega's commercial career. I wish you all a great evening.
Have you heard, Josh? Many first times outline this launch. But quite normal if you think that Vega means Veicolo Europeo di Generazione Avanzata, in English, European Vehicle of Advanced Generation. Vega is a precursor. We are on the way to the future of launchers.
Right. Flight Directorate, this time on the Vega side, Antonio Fabrizi and Stefano Bianchi of ESA. We had a last weather check at -10 minutes, right? What did they tell you?
Yes, people heard about the last weather checks at minus 10 minutes. It's a crucial moment to go through the automatic final sequence. Everything is still green.
A word on our three customers now. We'll be hearing from Thomas Panazzo of Arianespace.
As Italian, I'm particularly proud to be the ProbaV and VNRDSat 1 program manager of this second Vega launch, the first commercial of the light launcher of the Arianespace fleet. There's been quite a lot of challenge along the path from the very beginning of the mission preparation, almost 2 years ago, to the actual launch tonight. But I have to say that for this mission more than ever, it has been thanks to the commitment, hard work and strong spirit of collaboration between ESA, Arianespace, ELV, Avio and all the industrial working on the launch base that we could be ready for the launch tonight. 3 missions on board this second Vega launch. ProbaV for the European Space Agency. The satellite will be separated at 820 km altitude and will provide precious data for the monitoring of the evolution of the climate as well vegetation. VNRDSat 1 for the end customer, the Vietnam Academy of Science and Technology, from an altitude of 680 kilometers, will be able to generate prediction to monitor and anticipate natural disaster over Vietnam. Finally, S-Cube, the first Estonian satellite, will test in orbit the new technology of solar sails. 3 different missions which confirm the flexibility of the Vega launcher in satisfying 3 different customer needs. 2 new nations tonight, Estonia and Vietnam, will have in orbit the first scientific payload, and as you can see, this is just the beginning of a new adventure. Vega is ready to serve all the customers of the world in their low Earth orbit mission. Long life to ProbaV, VNRDSat, S-Cube and Vega.
ESA's role in this flight, the second Vega flight, is a little different from its role on the first mission a year ago.
Yes. As for the maiden flight, ESA is here with the Launcher Directorate for Vega. But tonight we welcome also our colleagues of ESTEC as a client. They are managing the ProbaV satellite.
So you can say basically that we've gone from a development phase, which was the first flight in February of last year, to development, from development to operational or even commercial phase. We have a reference, which is the first flight, but there's still elements that we're checking out to be qualified today. We'll look at those later. For now,
take a look now at what we call the launch campaign, or how the Vega is put together.
The campaign began on January 25th with the transfer of Vega's first stage, the P-80, from the booster integration building here at the space base to the launch zone. Here it was placed on the launch table. The Zefiro 23 and the Zefiro 9, Vega's second and third stages, were integrated to the P-80 on February 15th and 20th. Then the upper stage, called the Avum, was mated atop them on March 9th. The vehicle was checked and the Avum upper stage filled with its propellant. The 3 satellites arrived by air on March 9th at the airport in Guyana and were taken by road to the space base and the specially dedicated payload preparation buildings. ProbaV was placed on its adapter, then transferred to the satellite integration building called S5. The second passenger, VNRDSat 1, was assembled on its separation system, and its tanks were filled with fuel on April 9th. Satellite teams carry out all these operations in specially designed clean rooms here at the Guyana Space Center. S-Cube 1 was placed inside the support called PPOD, then on the same platform with the VNRDSat 1. This platform was then placed inside the Vespa carrying structure. Vespa allows Vega to carry several passengers at once. It's being used tonight for the very first time. On April 15th, ProbaV was placed in the Vespa, which was then covered by the twin halves of the fairing on April 17th. The composite was transferred to the launch zone and placed atop the launcher. The Launch Readiness Review gave the green light to begin the final countdown on the day before launch. On launch day, 2.5 hours before liftoff, the gantry that protects the launcher was moved back 80 meters, and Vega was now ready for her mission.
That mission due to start in just 4.5 minutes away. We want to say hello to all our friends taking the broadcast tonight.
Yes, hello to our colleagues at ESA HQ and Dominil, to our other ESA center across Europe, ESTEC, ESOC, ESAC, and especially Redu and Esrin, to which I say buongiorno frascati.
It's early morning in Estonia and Colleferro as well. Also hello to our friends in Hanoi, where it's coming up to 9 a.m. That's the DDO's voice. She's going to call out the 4-minute mark.
The 4-minute mark is beginning of a complex area of operation running.
Top, H0 moins 4 minutes.
This is the DDO, Amy Sip, who was the range operations manager, calls out milestones before and after liftoff. Why is the 4-minute mark so important?
It's important because it allows the liftoff and letting the launcher becomes autonomous.
It's the final part of the final countdown, I guess.
Yes.
Our cameras are here in the Jupiter Mission Control Building, but the CSG is a big base. A lot of people working at a lot of other places. One of them is up here at the Launch Management Center.
Yes, at this moment, engineers and technicians are following the final checks and verification on all the systems of the Vega launcher, which is done during the final sequence. Next important step for the autonomy of the launch vehicle is the commutation of the OBC, the onboard computer, which will drive the very last operations until ignition.
The Vega Launch Control Center is in the same building as the Ariane 5 Control Center. Mission control, where we are, is provided from the same Jupiter building. It's used for Ariane and Soyuz launches. We're about 14 kilometers away from the pad here in Jupiter. These men and women you're looking at are only about 3 kilometers from the pad.
Yes, but they are protected against any debris inside a sort of blockhouse.
Now, does this mean that there are 2 different control centers and all? Green status panels, continuing to tell the story, all is green.
Yeah.
Do we have 2 different control centers?
Yes, and we used to make similarities between the Vega Control Center and an airplane cockpit, and between the Jupiter Control Center and an airport traffic tower control. In Jupiter Control Center, the launch range manager, the DDO, gives the authorization to lift off once weather forecasts, radar systems, and other systems are okay. In Vega Control Center, people follow the fueling and check the good configuration of the vehicle for the flight. And then the launcher manager, the COL, decides to go.
Jupiter Mission Control here is the nerve center of the space base, the brain, if you will, of launch operations. The workstations you see there staffed by 3 teams in charge of the launcher, the satellites, and the base facilities. The room's divided into 2 parts. You can see the operational people on one side of the fishbowl, in the glass wall, and the VIPs and the guests on this side. The viewing room seats 250. Gives you a good idea of what's going on now, closer to the pad, a final countdown, as you can see, complex and ongoing series of maneuvers to ready everything, the launcher and the base and the downrange tracking stations for the mission. You can't just call out 3, 2, 1 liftoff and push a button. I think in the old days they used to be able to do that, but there are a lot of issues involved today, including safety. You're going to hear the DDO, Amy Sip, our first female DDO, by the way. She's going to call out the 1-minute mark in just a moment, and we'll be into the final 60 seconds.
À tous de DDO, attention pour moins 1 minute. Top, H0 moins 1 minute.
Final 60 seconds. Enrico, we're going to say goodbye momentarily to you.
Yes.
Enrico's going to go outside to watch the launch from the balcony. We'll see you in about 2 or 3 minutes. Huh?
Yes, it's a special moment for me.
All right. Tell us all about it when you come back.
Yeah.
It'll be exciting. There are 2 terraces where the guests and VIPs can watch the liftoff here. As we mentioned, the action takes place about 14 kilometers from here. You get a great view as Vega, I should say, passes. When he comes back, we'll get Enrico's reaction to seeing the liftoff live. You're watching the 2nd Vega flight from Europe's spaceport, Proba V, Vinredsat 1 and S-Cube 1.
À tous de DDO, attention pour le décompte final.
Final countdown.
10, 9, 8, 7, 6, 5, 4, 3, 2, 1, top. Allumage, décollage. La trajectoire est normale. Tous les paramètres à bord sont normaux.
Well, Vega lifting off perfectly from French Guiana, and right up she went rapidly in the light rain.
Acquisition de la télémesure
Don't know
lanceur
what
par
kind
la
of
station de
visibility
Saint-Jean-du-Maroni en Guyane
Enrico had
française.
out there. It looked like we lost Vega to the clouds pretty quickly. But she's
Tous
beginning
les
her
paramètres
second
à bord sont normaux.
mission a little over a year after her successful first flight. The DDO is calling out
La
all
trajectoire est normale.
is fine, all is normal on board. 137 tons at liftoff. Ariane 5, you might recall, weighs over 6 times that much. Those of
Tous
you
les
who
paramètres à
are
bord sont
familiar
normaux.
with the Ariane flights know the heavier launcher rises much more slowly than Vega. You saw Vega rise like an arrow, surprisingly quickly if you're used to watching Ariane lift off. Anyway, we were supposed to go, by the way, last Friday. We were technically ready, but we're held up by high altitude winds. But as you can see, we lifted off successfully
La trajectoire est normale.
tonight. All is normal on board. Basically, what's ahead?
Le pilotage est calme.
Vega's first 3 stages rise very rapidly in about 6 minutes. We're into the first stage burn. The first stage will burn another 20 seconds, flame out at about 1:55. The second stage will then ignite and separate at plus 3 minutes and 39 seconds. The third stage will ignite at 3 minutes and 55 seconds and separate at plus 6 minutes 18 seconds, and the AVM, the upper stage, will take over then.
Séparation du premier étage.
We've just had separation of the first stage. You heard the DDO call out. We have first stage weighing 97 tons, 88 tons of that fuel, all
Allumage
of
du
that
deuxième étage.
used up. We're into the second stage burn. And before we talk about the second stage burn, welcome back, Enrico. How was it out there?
Even if there were a lot of clouds, raining clouds.
You didn't see much, did you?
No, not
Tous
very
les
much.
paramètres
But
à
it
bord
was
sont normaux.
magnifico, you know, because at the beginning
trajectoire
you
est
see a
normale.
little spotlight on the launch pad. There is no sound. And it disappeared, the light disappeared, but then after there is a loud noise that arrives, the music of the propulsion that rolls you from the sky, and it makes you little vibration on your skin, you know, but not
Goosebumps,
little
then.
vibration, because it's a noise so high that it could seem an earthquake, you know.
La
It's
trajectoire
so
That loud?
Yes,
Wow.
that loud. It's
So you're impressed.
yeah.
Now, you've seen, this is not the first time you've seen a launch.
It's the first Vega anyway.
Tous les
It's
paramètres à
my
bord sont normaux.
I've seen 4 Ariane 5 before, which they are noisier, but for the little Vega, it's quite impressive.
Super. So even with the loss of visibility early on, you still had a lot of noise. You still had an
Yes.
impressive side.
Yes, and this noise, it's a mark of the power of the propulsion. You know, it's and even if you don't see it, you can feel it.
Good. Okay. Well, if that doesn't make you want to come down and watch a launch, folks, I don't know what will. Enrico, back to work. Sorry to put you to work. On the upper left-hand side of the screen, you have the cursor crawling up a line, and below that,
Séparation du
you
deuxième
have 2
étage.
lines, A and V. Can you explain to us what those are?
Yes, yes. The curve is a theoretical path that the launcher has to follow to accomplish its optimized mission. And the little A means the altitude of the
du troisième
launcher.
étage.
Below it, you can see a V, and it's the abbreviation of velocity and speed.
Largage
But
de la
on the
coiffe.
curve, that you can see a little dot that is moving, and that dot is the current real-time position of Vega, given by the data coming from
Tous
the
les
launchers.
paramètres à bord sont
All right,
normaux.
altitude 210 kilometers, speed 4 kilometers per second. Our top speed will be about 7.5 kilometers, so watch for that. While you were giving us that rundown, we had the separation of the fairing. You saw that, revealing to the elements probe V, which will be separated a little later on.
Mhm. Yes, the fairing is jettison
Tous les paramètres
because
à bord sont
outside
normaux.
the Earth's atmosphere, the fairing it doesn't need it anymore, and so we lightened the launcher of about 550 kilograms.
We're in the third stage burn. The Z9, as they call it, the Z9, the 4-meter-long Z9, though Vega's smallest solid propellant motor, has the longest burn time. She'll burn about 2 minutes, weighs 12 tons again. 10 of those 12 tons are fuel. So a lot of the weight
Tous les
of the
paramètres à
vehicle,
bord sont normaux.
like for Ariane, is propellant.
Yep.
Coming up on separation of the third stage, we have another minute to burn. Going back to the
pilotage est
fairing,
calme.
going back to the fairing, Industrial team is a big one. Italian, Spanish, German, Belgian, French, Swiss, Ukrainian, and Swedish firms all participate in design and development of the fairing.
Yeah, and the fairing on ground maintains a clean room environment for the precise instrument of the payload, and probably has a very sensitive optical instrument.
And we can release it now, as you said, because we're out of the Earth's atmosphere, and it's designed to protect the satellite from movements and thermal...
They protect against the impact of the dense atmosphere.
And of course, we're out of the atmosphere now, so we don't need it. We're coming up on extinction of the third stage, and then we'll have ignition, first ignition of the Atom. There's extinction. You can see it shutting off the nozzle. You hear the DDO call out the confirmation. You see our speed, and there's a separation of the third stage. Sometimes there's a second or two delay between the time the thing happens, the event happens up there, and the telemetry comes back here into Jupiter, which is why we get the animation a little bit first. But you see, we're doing well. The fourth stage has started its first burn. The fourth stage is called the AVUM, A-V-U-M.
Yes, for Attitude and Vernier Upper Mobile. Vernier referring to the thruster that are used for fine adjustment to the attitude or velocity of a spacecraft.
This is different from the lower stages, which use solid propellant.
Yes, exactly. This fourth stage is a liquid propellant engine, and it can be shut down and restart.
Basically, is it fair to say that solid propulsion, like on the first three stages, is used for raw power to get us going? And is it fair to say that the liquid propulsion is a little more sophisticated, used for precision?
Exactly, yes. Because the AVUM is designed to deliver payloads into different orbits and to perform very fine satellites pointing before separating them.
We've been picked up by a downrange tracking station in Bermuda. Vega will pass over it twice. On its first pass, it'll see extinction of the first AVUM burn. Vega's trajectory has been designed to be followed from the ground at all times. The launcher, is sending back radar and telemetry to these downrange stations. Now, what's telemetry?
Yes, telemetry is the way we have to stay in touch with the launcher. The downrange telemetry stations receive electromagnetic waves that brings information, thousands of parameters and indicators of Vega health in flight, motor pressure, stage separation event, nozzle activation, and so on. We analyze some of this data in real time, so we know where the satellites have been released, for example. The other data are examined after the flight to find how the vehicle performed. We have downrange telemetry stations in most of the places of the flight by the launcher: Bermuda, Perth, Saskatoon, Lucknow, added to those in French Guiana.
Our altitude, 274 kilometers. Our speed, 7.74 kilometers per second. We're going to go shortly to a replay of the liftoff, a medley, I think, of launch replay shots from different places. You'll be able to see for yourself, once again, those good, very interesting pictures that took place about 8 minutes ago. We're following the second Vega mission. Here's the replay. What that made you recall the moments that you spent out on the balcony there? What went through your mind as you saw those shots?
It recalls my previous job in CNES. I participated to the design of the ground segment of Vega with the people of Esrin and Industrial as VV02. It was quite hard to answer to all the requirements of Vega, but now it becomes real.
The real thing. AVUM carrying 626 kilos of propellant in her 4 tanks, powered by a restartable engine, as we mentioned, and we're going to have 5 burns on this flight. What do we need 5 burns for?
Yes, so the 2 first burns are necessary to target the 820 kilometers of the circular orbit of ProbaV. You know, the following 2 are for the benefit of the orbit at 670 kilometers of VNREDSat and S-Cube. Then after, we have the 5th and last one, which is necessary to deorbit the AVUM following a safe and predetermined trajectory over the Pacific Ocean. The space debris mitigation is one of the very important innovations of this launch.
I think on the first Vega launch, lasted just over an hour. Tonight's will be over 2 hours. And the AVM, at that time, we had 3 burns, and today we have 5.
Correct, yes.
There are other differences, which we'll get to in a moment. But for the moment, we are in the middle of the first AVM burn, which will burn again for about another 30 seconds. Then we'll have a ballistics phase, a coasting phase, which will last about 3/4 of an hour. Then the AVM will reignite for the second burn. It lasts about a minute and a half. They're short burns and they're long burns.
Yeah.
Shortly after that, Prova V will be separated at about plus 55 minutes and 26 seconds. Then there'll be a third AVM burn, and a fourth AVM firing will prepare the separation of VinRedSat and S-Cube. If you're looking ahead, VinRedSat separating at 1 minute and 57 minutes after launch, and S-Cube 1 released about 3 minutes after that. Coming up on the end of the first AVM burn, should hear the DDO.
Première extinction du 4e étage.
There we go. She's called out the first flame-out extinction of the upper stage. And you see our speed on the lower left is 7.96 kilometers per second. I think that's going to be about our top speed, because we're going to be changing speeds now.
Exactly.
Let's go back down to Earth for a moment. Enrico, talk about the launch pad, if you don't mind. Vega's pad was built on the old Ariane 1 pad called ELA-1, which was decommissioned in 1989. But its history goes back even farther.
Yeah, even before Ariane, the initial launch pad, that launch pad was built for the 3 stages launcher Europa in the beginning of the 70s. Europa was the first European collaboration in a launcher sector and the precursor of the current Ariane launchers family. That adventure gave birth to ESA.
More of the mission in a moment, but for now, as promised, the second part of the latest news from Arianespace, including a lot of contracts. Take a look.
On February 7th, Arianespace launched successfully for the 54th straight time, lifting into orbit 2 new telecom satellites, Amazonas 3 for Spain and Azerspace Africasat 1A, the first satellite for Azerbaijan. The mission set a record for mass delivered on geostationary transfer orbit, 9.5 tons.
Eutelsat and Arianespace announced the nature of a new contract for launch of several satellites on February 8th. The agreement guaranteed Eutelsat new resources and flexibility in order to carry out a program to expand and grow its satellite fleet.
In Sydney on March 4th, with French and Australian ministers looking on, Arianespace signed a new launch contract for the new Australian operator NBN. The 6-ton satellite will be launched in 2015 on an Ariane 5.
On March 18, Intelsat chose Arianespace for the launch of 3 new telecom satellites in the 6-ton range. The signatures brought to 54 the total number of contracts signed between Arianespace and Intelsat over the years.
France's Minister of the Interior, Manuel Valls, paid a visit to French Guiana on March 8th. He toured the Guyana Space Center facilities along with representatives of Europe's space industries. At the end of his visit, he congratulated the CSG teams, saying he was quite impressed by what he saw.
Le pilotage est calme.
Arianespace was present at Satellite 2013, one of the big conferences for members of the global space community, which took place in Washington, D.C. from March 19 to 21.
For its 20th birthday on April 12th, Japanese operator BSAT awarded Arianespace its Certificate of Appreciation for the company's launch services and solutions.
3 missions are being graded in French Guiana right now. The next Ariane 5 launch is just a few short weeks away. Flight 213 will lift the 4th Automated Transfer Vehicle, or ATV, called the Albert Einstein to the International Space Station, bringing food and supplies to the astronauts on board.
The 5th Soyuz flight from French Guiana is set for late June. It will carry the first 4 satellites in the O3b constellation. This fleet will provide internet access to those living in regions where no online service is yet available.
Preparation for Ariane Flight 214 got underway here on April 24. The mission, set for the end of July, will place in orbit 2 new telecom satellites, AlphaSat for Inmarsat and INSAT-3D for ISRO, the Indian Space Research Organization.
Enrico, our satellites are going into SSO, Sun Synchronous Orbit. What's that all about?
Yes, tonight Vega will release our 3 clients on 2 different SSO orbits. As I said before, 820 and 670 kilometers, different altitude and different inclination. Typically, Earth observation satellites are on sun-synchronous orbit. It's an orbit which combines altitude and inclination in such a way that satellites fly from a pole to the other, crossing the equator 12 times a day, each pass at the same local solar time. For ProbaV, it will be at 10:45 a.m. and VV02 at 10:41 a.m. In such an orbit, satellites are in a constant sunlight, and it's very useful for imaging satellites because shadow will be nearly the same on every pass.
We mentioned Jean-Yves Le Gall has moved from Arianespace to CNES, the French Space Agency. An interview now with Mr. Le Gall.
Hello, so here we are today for the second launch of Vega, the small launcher of Europe. Not that small, actually. And the CNES, as you know, has been a major stakeholder in the development of Vega because the first stage of Vega, P80, was co-developed by the launcher department of CNES. And after the first huge success of the first Vega launch last year, we are now moving forward a new step in the development and implementation of Vega. As far as we're concerned, it's actually the first that will take place since my appointment on April the 3rd as president of CNES. So it's a new step which we are all taking together, and I'm of course very, very happy to be here today for this first launch.
We mentioned that the mission of the first Vega launch was to qualify the overall Vega system, including the vehicle, the ground infrastructure from the launch campaign to payload separation, all the way through to the disposal of the upper AVM module that demonstrated the correct behavior of all the elements for the launch system in real conditions. You can't do that except in real conditions. But we're still demonstrating certain elements tonight, in particular the VESPA system.
Totally correct, yes. VESPA means Vega Secondary Adapter Payload. It is in order to improve the customer service. New payload configurations are qualified so. This evening, this VESPA structure will extend the Vega payload launch capabilities for multiple payloads. Vega will be better tailored for its specific market of mini-satellites.
Very good. Up next, you'll see how Vega can orbit her different payloads, and we'll be back with more of the mission afterward.
After its successful qualification flight on the 13th of February 2012, Vega is on the launch pad ready for its second mission. This time Vega will show its full potential with 3 different payloads: ESA's ProbaV, the Estonian CubeSat, and a satellite for the Vietnam Academy of Science. This delivery is possible thanks to a new multi-payload system called VESPA.
When you will have this stack integrated, on top you have the Proba satellite. The Proba satellite will be the first one to separate during flight with its separation mechanism. Then the upper part of this VESPA structure will separate and then allowing to then perform the separation of the secondary payload, the VV02, which is placed inside the lower part behind you.
The flight will be completed with the separation of the small CubeSat. This launch is also the first of a series entitled VERTA, for Vega Research and Technology Accompaniment, aimed at the smooth introduction of the launcher to commercial service. 5 launches are planned for this transition phase between ESA, the developer, and Arianespace, which runs Europe's launches. This second flight will confirm Vega's capacity to send multiple payloads, as well as Europe's guaranteed access to space. Now with Vega, Soyuz and Arianespace is able to launch any satellite into any orbit from Kourou.
Enrico, they mentioned VERTA, V-E-R-T-A, in the film, also being qualified tonight. What's the VERTA program?
Yes, as they said, it means Vega Research and Technology Accompaniment. It aims to demonstrate the flexibility of the Vega launcher. For example, the flight program software is new. Its implementation and flexibility for the different possible missions of the launcher are today improved. It also comprises a production accompaniment. The introduction of Vega for commercial exploitation in a cost-effective way is smooth.
There are 5 more Vegas ordered under the VERTA program. I think that was mentioned. They're currently in production. The flights make up a program to support the initial operations of the early Vega launch system. VERTA was approved by ESA in 2005, and the payloads have been pretty much designated for most of the flights, haven't they? The next one is in July of next year.
Yeah, then after in 2015.
A film up next now on the VERTA program. You'll find out more about ESA's VERTA activities.
On the 13th of February 2012, ESA, the European Space Agency, launched the very first Vega rocket into space, a successful qualification flight. Now the second Vega is on its launch pad, protected by its preparation tower in Kourou. This will be the first of 5 demonstration flights, part of a program called VERTA, for Vega Research Technology and Accompaniment, to support and secure the initial operations of the Vega launch system. The aim is to allow a smooth introduction of Vega for its commercial use and exploitation by Arianespace.
The VERTA phase is an initial exploitation accompaniment phase, which is necessary in order to, let's say, to accompany the actual commercial exploitation in the early phase of the development of the launch system. This allows to lower down the cost, so to make the launch service more appealing, and to improve the customer service. In this first VERTA launch, we introduced improvements in the launch service, the main one, the most visible one, being the multi-payload capability of the launcher.
Here in Kourou's clean room, the upper part of Vega is being readied for launch. This multi-payload relies on a specially developed adapter for Vega. It allows Vega to be used to its full potential by lifting several payloads simultaneously into orbit. This second Vega will carry 3 satellites, Proba V, the Vietnamese VNR-DSat, and an Estonian CubeSat.
So this is an important qualification for Vega because it'll extend the single launch capacity to a multiple launch capacity, meaning as for Ariane 5, we will be able to have 2 normal paying customers in addition to the CubeSats, as we have done for the first flight and as for this flight, if we need to.
The Vega launcher comprises 3 solid propulsion stages with a 4th stage ARVM, with liquid propellant and a reignitable engine. It can be fired up to 5 times in space, delivering the satellites not only to different orbits but also in different inclinations, a key asset for Vega's commercial operation. That is why Vega represents an important introduction to the European launcher market and guides the way for ESA's future launcher development.
In ESA we look ahead for all the family of launchers, and that's the reason why we are conceiving Ariane 6. Ariane 6 is the launch vehicle that we shall need in the future to stay on the market in a fully competitive way, so that the customers can be launched when they really need and at the cost that is competitive. So this is the challenge of Ariane 6.
ESA wants to ensure that Vega becomes a reliable, low-cost launcher for small satellites. This second Vega flight marks the handover from ESA to Arianespace. It also marks the evolution of future launches, particularly Ariane 6, approved by ESA member states at the Napoli Ministerial Conference last November and confirming Europe's continuing independent access to space. Vega's career is only starting, but with Vega, Soyuz and Ariane at Kourou, Europe can now launch any satellite on any orbit.
They mentioned Ariane 6 twice in that film. That's the future. What do you know about Ariane 6?
I think that Ariane 6 will pursue the work initiated with Vega by transposing new technology proven previously. I think about composite fiber cases or the electrical nozzle actuator. You know, today, large solid boosters with composite casing are considered as the baseline for the booster, the first stage and the second stage of Ariane 6.
The links between the 2 launchers, between Vega and Ariane, are considerable. It's surprising. Without Ariane, you don't have Vega. Now, without Vega, you don't have Ariane 6.
Yeah, there is definitely a legacy.
Turning to the satellites, you can see exposed to the elements Proba V, that's the silver box on the right. Underneath that, the black triangle is the Vespa, which will be separated afterward. Up next, a look at Proba and Vega with the Proba V Satellite Mission Director, Karim Melab.
The Proba program was initiated in the 1990s with a clear determination of demonstrating new technologies in orbit. Within that framework, Proba 1 and Proba 2 were launched in 2000 and 2009 and have been orbiting to test these new technologies. Proba Vegetation is purely a Proba satellite in line with Proba 1 and 2. It's a technical demonstration platform with an operational observation mission, observation of the vegetation. Proba 1, Proba 2 and Proba V, beyond that, we aim to continue that with a new satellite or two that will be called Proba 3, and which will have as a purpose the demonstration of formation flight. Vega was chosen because it's a highly agile launcher that can have these specific types of missions such as we will have tonight. Multiple launches, Proba V, VN-REDSat, a demonstration of the re-entry of the last stage. This type of launcher is very interesting for us institutionally to test and embark very different types of satellites. Over the past 6 weeks, the work we carried out here was truly outstanding. The nature around us is very pleasant and has allowed us to work in very pleasant surroundings. And the installations allow us to work and relax and prepare the satellite for the launch. As soon as the launch has been performed, we will go to Redu in Belgium to track the satellite, and we have 6 months' work before us.
We spoke with Karim Melab last night. He told us a couple of interesting notes concerning Proba V and the next ATV, which is called the Albert Einstein, as you know, that's scheduled for launch here in June and is currently in its preparation phase here, I should say. The first one, when Proba V was transferred from one satellite building to another, from the S1 building, to be precise, to the S5, it rode in the same container built for the ATV.
Yeah.
I don't know if you realize, but the ATV weighs 20 tons.
Yeah.
And Karim's satellite weighs 138 kilos. And he said as his team and he watched their small satellite absolutely dwarfed in this huge container, they, amid all that space, they were almost afraid it was going to get lost. You saw in the pictures in the launch campaign that we had, I don't know if you recall. The second thing was, when Proba V came to the same satellite preparation building, it came to the exact same spot where the ATV had been until 2 days previous. Oh, and the ATV moved to another room. So Karim said you had the ACE's biggest and smallest satellites at the same place, at the same time. Next, a film about Proba.
The European Space Agency, ESA, works at the forefront of new satellite technologies and scientific breakthrough. This is where Proba satellites come in, as an orbital test platform for new technology. Although ESA can simulate some parts of the extreme space environment here on Earth, it's not sufficient and can never replace the full conditions of space itself.
To make sure, or to give the confidence that that technology will actually work as advertised, you really need to be in orbit. And that's where the microsatellite that we use in the Proba series come up. They help us to get the final validation for a technology.
The Proba family is a set of small, simple, robust satellites using materials with proven reliability. Although they are relatively low cost and are the size of a washing machine with solar panels, the Proba satellites are packed with innovative instruments and offer a great testbed for research. Proba stands for Project for Onboard Autonomy, which means that these mini satellites are smart enough to manage themselves in space. ESA launched the first such satellite, Proba 1, in 2001. Its mission was to demonstrate a new type of environmental monitoring instrument, measure radiation along its orbital path, and test a new generation of batteries. It's actually still being used today for Earth observation, and this success has opened up new opportunities.
In the case of Proba 1, which gave the name to the series, it was the autonomy on orbit of the satellite itself. And then we send out an AO saying, we want to try this. This is the spacecraft on which we're going to do it. Who out there is interested to use it for a mission, for a scientific mission? So we have what we call a payload of opportunity.
The experience was repeated in 2009 with the Proba 2 satellite, and this time the success of the experimental payload was even greater. While in space, Proba 2 continuously monitors solar activity and space weather, sharing its data with solar scientists and meteorologists worldwide.
This is really the way to go, and this effectively achieves what we want. They gotta stay small, they gotta stay fast, and they gotta stay cheap, but at the same time, we need to do more innovation, more innovative missions in this sense.
And the innovation continues, as ESA is developing a pair of Proba 3 satellites demonstrating formation flying in space to study the Sun from 2017. And now ready for launch from Kourou aboard Vega is Proba V, V for vegetation. This is the first time a Proba satellite has been assigned an operational mission from the start. It will monitor vegetation growth on Earth daily with a compact new imager. But being a proper prober, the new mission also carries with it some technological demonstration payloads, including an innovative system to track aircraft in flight around the world. Sometimes with small, you can think big.
You're watching Arianespace's second Vega launch with 3 satellites, Proba V, VinRedSat-1, and S-Cube. Enrico, you were here during the campaign. What impressed you the most?
What impressed me the most? I think the great care that everybody had taken to limit as much as possible any contamination on Proba V optical instruments. You know, these sensors are very sensitive.
It's an ESA mission dedicated to demonstration of innovative technologies, as was mentioned. I don't think anybody mentioned that the Proba satellites are ESA's smallest.
But it's true.
Smallest satellites, right. Small satellite, big missions. Proba V was developed in Belgium. New instruments on board make it an improved version of its predecessors, they mentioned in the film, launched in 2001-2009. Our next film, another look at Proba Vegetation. V for vegetation. We'll be back.
ESA's Proba family is soon to be extended with a 3rd satellite that will send into orbit Proba V. V for vegetation. While earlier Proba satellites were in essence demonstrators for testing new innovative technologies, Proba V will be the first Proba satellite assigned an operational mission from the start of its development. This new Earth observation satellite will deliver information continuously about the status of vegetation across our whole planet. And it also embarks experimental technology payloads.
That is one of the elements that promotes the Proba program, is to fly new technologies and to be precursor on certain number of domains before it goes to operational satellites or to demonstrate that this technology is valuable for the future.
For example, key technology payloads on board the Proba V are a new reception system for air traffic communications and a new high-density fiber optic system. But vegetation is the absolute key to this Proba's mission. The vegetation payload has been flown aboard French Spot satellites since 1998. But as there was no room for it on new Spot satellites, ESA opted for a dedicated Proba platform. So Proba is now a small satellite with the vegetation instrument as a big payload. A major change for the industry, in particular for the Kinetic company.
The original vegetation payload is bigger than the whole spacecraft that you see behind me. What we needed to do is to miniaturize the payload so that it could fit on a Proba-like satellite. And with the new technologies that have been developed in the optics, we have actually been able to reduce the size and the mass of this payload to fit on the standard Proba platform.
Although the payload is smaller, its performance has actually improved. Thanks to instrument advancement, Proba V will be able to cover a swathe over 2,000 kilometers of the Earth's surface at every pass, double the previous range. This enhanced payload will give scientists a daily overview of the global vegetation growth, and will also guarantee the continuation of the existing vegetation dataset, thereby playing a key role in Earth observation.
Proba V will give us an indication on the status of the vegetation, but also on the changes, and those changes can occur either within a year or also between the years. This will give us insight into the changes of the land cover and of the vegetation, and will help us to look at, for example, changes introduced by mankind, agriculture, forestry, and usage of the land cover.
A small but smart satellite. rover is a solid illustration of what space can bring. And with this vegetation mission, another technological achievement that will help us better understand our planet.
Turning to our second passenger, VinRedSat, the third satellite. It will be launched by Arianespace for the nation. VinaSat 1 went up in April 2008 on Arianespace flight number 182, weighing 2.6 tons. And VinaSat 2 launched in May of last year on flight 206, weighing nearly 3 tons. You can judge by the weight that both of those satellites could not be launched tonight on Vega. They were launched, of course, on the heavy, Ariane 5. Here's something I bet you didn't know. Vega was one of the names proposed in 1972 for what became Ariane. Did you know that?
No, I think I was too young.
Were you born at least?
Yes.
1972. Other names were Phoenix, Lyra, Cygnus, Ganymede, and Penelope.
Wow.
Up next, an interview with the satellite mission director for VinRedSat, Brigitte Tedaldi of Astrium.
In the framework of the VinRedSat-1 program, Astrium will give Vietnam and VAST, Academy of Science and Technology, its first system of Earth observation. It is an optical satellite which will be in heliosynchrone orbit at 680 kilometers. It is part of the range of the AS100 product that Astrium has developed in partnership with the CNES and has delivered for numerous satellites. Together with the satellite, Astrium has also provided all the ground segment, which allows to check the satellite, but also to acquire and to process the images. Astrium has also trained a team of 15 Vietnamese engineers who will become responsible for the operations of the system as a whole. Astrium, as a major industrialist, must find the best solutions to meet the needs of its clients. Today, Vega provides a wide range of satellites with a great variety of orbits. Vega allows multiple launches with the Vespa structure made by Astrium in Spain, and therefore Vega presents advantages since it allows optimized launch configurations. In Kourou, the Ariane 5 Soyuz range, and now Vega, will enable us, industrialists, to make proposals of optimized configuration launch. And for our commercial offer, this is a major asset, since we are always looking for program possibilities.
Everything is okay on board, as Vega is performing flawlessly. The fourth stage is flying. We're in a coasting phase right now. Enrico, you helped design the Vega launch pad. That was in an earlier job you had.
Yeah, the big deal was the mobile gantry. The principle is to have the same as for Ariane first. The mobile gantry is used to integrate and test the launch vehicle. You know, the mobile gantry is a tower tall about 50 meters and heavy 1,000 tons, quite a lot. Then it is moved away 100 meters back, quite a challenge to enable the launch. This mobile gantry hosts other facilities which enables the integration of the stages, crane, platforms, the system used to check of other stages and to fuel the last stage.
All right, staying with Astrium, builders of VinRedSat 1, our next film, an interview with their CEO, Eric Beranger.
We are extremely proud that Astrium is building the first Vietnamese Earth observation satellite, VinRedSat 1. With this satellite, Vietnam will join the exclusive club of satellite owners. Let me finally thank all partners involved. VAST, our Vietnamese customer, who entrusted us with building their first satellite. Not to forget, under the leading and determined vision of Professor Min. The French authorities for their close involvement in the building and nurturing of the cooperation, and for their help at key points of the program. Arianespace, ESA, and CNES for their support and professional service for launching the satellite. And of course, the Astrium Satellite project team and the Astrium Satellite suppliers for their excellent work.
Let's talk about who does what in the Vega program. Shall we start with ESA?
Yes, ESA was responsible for the implementation of the program and of its technical and financial management. As is, the Italian Space Agency provides 50% of the funding and also has a large management role. CNES, the French space agency, led the project team for the P-80 stage development and was involved in the combined test campaign.
Arianespace, as with Ariane and Soyuz, holds exclusive rights to operation, marketing, and sales of the Vega Launch services, also supervises integration and inspection of the launcher that's built by ELV, the prime contractor.
Yes, ELV holds industrial architect responsibilities and is the industrial prime contractor. Avio is the program primary industrial partner, and Vitrochiset is the prime contractor for the ground segment.
Over to Mart Norma now, the mission director for SQ1, for a look at the first Estonian satellite.
SQ1 is a one-unit CubeSat satellite which mission is to demonstrate advanced centrifugal tether deployment on low Earth orbit. This is the first step towards development of a novel spacecraft propulsion system for space debris mitigation and interplanetary space flight called the electric solar wind sail. In addition to its scientific mission, SQ1 is mainly an educational program. It is developed by the students from Estonia and 6 other countries in cooperation with Estonian, German and Finnish space research institutes, led by the Tartu Observatory and the University of Tartu. Since the start of the project in 2008, almost 100 students have contributed to the project. Our team is very happy that we have the opportunity to launch our satellite on board of the new Vega launcher. This is a part of the cooperation between Estonia and the European Space Agency. Estonia has currently the status of the European cooperating state with ESA, and we hope to become the ESA full members in the near future. Estonia contributes already to many ESA activities through the PEX program, and our young engineers from the SQ1 project definitely hope to contribute to the ESA big satellite missions in the future. At the same time, the Student Satellite program will continue to be the flagship initiative for science popularization and engineering education in Estonia. Thank you.
Enrico, he mentioned ESA's PEX program. What do you know about that?
Yes, the PEX is a program for European cooperating states. For European Union members who are not yet ESA members, a cooperation program giving them a way into ESA, a sort of a bridge, you know. They can learn to deal with ESA, and show ESA what they can do. It's a political decision to join ESA, and so many countries for Eastern Europe have gone this way. Czech republics and most new European Union members.
CubeSats on the first Vega flight were built also by university students in Italy, Romania, Hungary, Poland, France, and Spain. ESA has a comprehensive educational program which encourages such projects. A look now at Vega's commercial future with Louis Laurent and Jacques Breton of Arianespace.
From the operational point of view, the organization which we have set up for this demonstration launch constitutes a transition between what was done during development and what we shall be using during the operation of Vega. The organization is based on a few key principles. The first is a breakdown of functions between the stakeholders, in line with what we habitually practice with Ariane and Soyuz, and which has been very effective over the years. The second is the use, when necessary, of the expertise developed in the Italian industry to process specific issues. And the third is to maximize synergies between the operations of Ariane and Soyuz in order to benefit from the experience of methods which have been developed over the years on these launches. Going forward, we have three key working developments. The first is to leverage this launch to draw every lesson that we can, what we have learned during the campaign and the launch. The second is to move from a one-by-one operating production to a series production, what is known as the industrialization phase, which is a classic approach in our business, consisting in improving quality, reducing campaign length, and reducing operating costs for Vega. The third is to increase the rate, to ramp up. The prospects of Vega's market are excellent, and we wish in the short term to ramp up to 3 launches per annum, which will require a certain number of investments. And we shall be working, as of tomorrow, in this direction.
With the second launch of Vega today, Arianespace, ESA, and the industry demonstrates that the Vega launch system is available and reliable. In 2011, we signed the first contracts for launches on Vega for Sentinel-2B and 3B. Last year, we signed the first export contract for DZZ of Kazakhstan, a satellite built by Astrium. And I expect that this year, after this successful launch, we will positively conclude some discussions going on in the Mediterranean area in particular. So I expect some announcements to be made in the coming weeks. Stay tuned. Vega is a perfect launch system for small missions, for Earth observation, scientific missions, technology demonstration, a perfect way for countries wishing to enter the space world to launch their first mission. There is a potential for Vega. We have now to turn it into a commercial success, as we did with Soyuz and Ariane 5. In that respect, this year, 2013, has already been a success, as we have already signed and announced 7 launch service contracts for satellites to be launched by Ariane 5.
The launcher Vega will have a big future in the small satellite market. In the late 90s is when space agencies worldwide started developing small satellites, huh?
Yes, and the small satellite market is growing. ESA estimates that between 2009 and 2011, for example, 7 single payload launches could have been performed by Vega.
Other studies report that an estimated 5 to 7 satellites, small satellites, should be available every year between 2010 and 2015, all heavier than 250 kilos and therefore compatible with Vega. That means 1 ton, 1.5 tons into polar orbit.
Yeah. Or
in a low Earth orbit. Typical Vega missions of the future will be sun-synchronous orbit. Is that what you expect? Small satellites like tonight's with multiple passengers.
Yeah.
In our last film tonight, we'll continue our series of profiles of professions here at the Space Base. A look now at a launch site operator.
My name is Alexandre Massé. I'm an Arianespace engineer, age 32, and I'm electrical assistant for the Ariane 5 and Vega campaigns. I started my career with an experience as a test and validation engineer for the Ariane 5 flight program. I then integrated the operations and launch arrays division at Arianespace, and with a very extensive scope with the 3 launchers, Ariane 5, Soyuz and Vega, which need to be operated and maintained. I worked on several specialties and am now a deputy assistant at the digital and software section in charge of the control benches and electrical systems, flight controls and launcher measures. After the first successful launch of Vega, ESA entrusted us the operation of this launcher. Arianespace's work is now to provide maintenance and operations for the Vega launch system. Applying the same methods across Ariane and Vega is all the more easy that some of the software and electrical systems are identical. We have started optimizing the processes, and we can leverage the experience acquired through Ariane 5. My team is constituted of specialty managers in guidance, navigation and control, as well as safeguard, pyrotechnics and sequencing. We perform functional operation control and operational controls with specialty managers and electrical specialists. We provide controls of the software and electric system, for instance, through nozzle control. And on Vega, these controls on the nozzles are performed on the 4 nozzles on the 4 stages. Here we are at the 4th level of Vega, where this box here has been installed to perform all of the verifications of interfaces between the launcher and the upper section. All of these controls are provided from the control center and allows us to verify before integration of the upper section. During a campaign, the electrical assistant manages operations of the electrical and software and pyrotechnic systems and assists the COEL, DDO, in all these operations. Between the COEL and the DDO, there is an exchange of status reports, red lights and green lights, which follow a certain number of rules of inhibition or acknowledgement, either automatic or manual. The operation performed by the electrical assistant with the DDO is therefore to verify that data exchanges are functioning properly. What's very interesting at Arianespace is that you can work on a great variety of jobs with teams from all over Europe for Ariane 5 and Vega, and with teams from Russia for the launches, the Soyuz launcher.
Interesting films give you an idea of some of the other jobs going on here at the space base, over 1,500 people in all. Proba V separation due now in just under 4 minutes. While you were watching that film, we were picked up by our next downrange tracking station in Perth. The Australian station will see the second AVM firing, which is coming up in just about a minute. Also separation of Proba V. There will be a final downrange tracking station, that's at Lucknow in India. The station will see the 5th and final ignition and extinction of AVM. That comes at 2 hours, 17 minutes into the mission. We won't be here, but this is to deorbit the vehicle. Now, why do we need to deorbit the vehicle?
Yes, today we are more sensitive to the space debris, and it's not anymore acceptable to leave things that are not used, as it was done in the 60s.
Yeah, it's a big question, space debris.
Yeah, very big. There was a conference about 3 weeks ago. And so we deorbit the AVM in order to leave space clean. Huh? And it happens with the 5th burn that we mentioned before. AVM, it's lowered down and into an orbit low enough to ensure within a few years a re-entry into the atmosphere where the stage will burn.
DDO has just called out, and you can see the beginning of the second AVM burn coming right on time at about 822 kilometers up. Our speed 7.4 kilometers per second. Why do we need the second burn?
So you've seen after the first burn, the launcher was in a ascent on an elliptical orbit to join the altitude of 820 kilometers. You can see it on the
upper left, yeah.
Yes, on the upper left, the path. Yeah. So now, during the ballistic phase, the initial speed was transformed in altitude, which grows up. Now, with the second burn, the launcher speed is speed up to the velocity of 7.5 kilometers in second in order to have a circular orbit at 820 kilometers, into which we will release the satellite.
Because we had our top speed, which was almost 7.9, I think more than 7.9 kilometers per second, and then we slowed down and we're speeding up again.
Yeah.
So that's the advantages of the reignitable upper stage, I guess.
Definitely.
All right, we're coming to the end of the second AVM burn. just in about 1 or 2 seconds, you'll hear the DDO call out confirmation of that. There's the nozzle shutting off. And by the time the telemetry comes in here to
Extinction
Jupiter,
du 4e étage.
there it is, extinction of the 4th stage, he says. So now we're coasting again. On the right is Proba V. The black triangle under that is the Vespa, that's the carrying structure.
Yeah.
And under that, the black part is,
Début de la manœuvre d'orientation au
inside of
profil
that
de Proba
are
V.
the other 2 satellites.
Yes. VV02 and IceCube.
Proba V separation coming up at, I would
Fin de la
say,
manœuvre
about
d'orientation.
10 seconds. 4 years in preparation, readying it for tonight's mission. Separation of our first passenger imminent. As you can see, technicians here in Jupiter have their eyes on their computer screens, ears to their telephones, waiting.
Séparation Proba V.
And there it is, the first good news. Separation of Proba V.
Yeah.
And Vega, as you saw very politely, the folks here in, well, I was going to say they were holding their applause until the final passenger, but I spoke too soon.
Yes, it's with the people.
Maybe that's the Proba team.
Yes.
Now the Proba is up. What are its first early orbit operations going to be?
Yes. So Proba V, when separated, is switched on and stabilized, stopping its tumbling. It's a kind of a barbecue movement in order to heat on all its sides during the ballistic phase.
Right, they have to heat equally each side, so it's got to turn and turn and turn.
Exactly.
Right.
So then, just after 40 minutes after separation, Kourou ground segment will be able to acquire its first signal. Then, 70 minutes after separation, the satellite will fly over Svalbard in Sweden. And the first communication... Norway, sorry.
We're going to go to a launch replay again, this time maybe from another site. Fine shots again. You didn't see much of her trajectory as she lifted up, but you did see the very quick ascent of Vega as she lifted very rapidly off the pad.
And I repeat, the noise.
And the noise. That's going to be with Enrico for, I think, a long time to come. We're going to take a break while Vega is circling the globe. We'll be back in about 45 minutes at plus 1 hour, 49 minutes local time for the end of the mission. You don't want to miss it. You'll see separation of our second and third passengers. In the meantime, you can follow the action on the 3D animation and on the curve on your screen. So enjoy it, everybody. We'll see you back here in 3/4 of an hour. Well, we are back. Joshua Jempel here with Enrico Posamai. If you just joined us, you missed the first part of the action. Proba V has been successfully separated by Vega. But not to worry, 2 more satellites remain to be sent into orbit. Our second and third passengers, VinResat-1 in 7 minutes, and SQ-1 at about 10 minutes from now. Enrico, give us a recap of everything that's happened, will you, since 23 hours local time?
Yes, so after liftoff, Vega headed for the North Pole, made half a round on Earth, injected Proba V into its orbit when it was above Australia. We followed all the activity thanks to the Perth downrange station. A third burn of the Avum slowed down the launcher into a new inclination of the orbit. It's as the launcher was going down a kind of slope to join a lower altitude, the altitude of 680 kilometers for the VinResat and S-Cube satellite. The speed will rise until 7.65 kilometers per second as the altitude will diminish with respect to the Proba V orbit. The next step will be the separation of the Vespa structure
coming in 2 seconds.
Yes, in order to free the satellites.
Séparation de la partie supérieure du système de lancement double Vega.
And right on time, coming up is on the Vespa separation.
Yes, and then the AVUM stage will maneuver to point correctly the satellite before releasing them.
All right, you can see VinRedSat exposed to the elements now. That's the silver box. We know all this information because we're being tracked by the downrange tracking station in Saskatoon, which acquired the signal about 3 minutes ago. Saskatoon sees separation of the Vespa, which we just saw, and the fourth AVUM ignition and extinction, and then the station will also see separation of VinRedSat and S-Cube-1. Now, how does separation happen? We have a clamp band system. Is it like on Ariane 5?
Yes, it's the principle. It's as the Silda one. You know, it's a.
The Silda is the carrying structure that allows Ariane 5 to have a second passenger, like Vespa allows Vega to have another passenger.
Yes, as its name, Vespa, Vega secondary payload structure, and so it allows to bring another mini satellite inside the structure itself. The separation of the Vespa is achieved by means of this clamp band. And it's in order to open the two half shell in order to free the satellites which are inside. The band separates the Vespa along an horizontal plane at a mid-level of the cylindrical part.
Well, that's like the Ariane system, roughly. It separates into two halves, I think, as well.
Yes.
The fourth AVUM ignition will be burning for another 30 seconds, roughly. And what's going on now, aside from the similarities between the separation systems of the Silda in Ariane and the Vespa for Vega, we're also in sort of a ballistics phase, I guess you could call it, right? Where we have ignition, and then for a period we don't have ignition.
Yes.
How would you explain that?
But
in between the satellites, we have to maneuver the composite into different orbits, different
altitude and different inclination of these orbits.
Tous les paramètres à bord sont normaux.
On Ariane 5, we can only aim only one kind of orbit. It's for that reason that on Ariane 5, when you have two satellites, they are always both on
geostationary transfer orbit, right? GTO, if you've heard that.
Exactly.
But that's not where we're going tonight. In GTO, we have to go towards the east.
Yeah.
Tonight, we go towards the north. We're in the fourth AVUM ignition, by the way. So we're in another powered phase. Now, for guidance, the AVUM is using clusters of thrusters for roll and attitude control. Now that's what the Ariane does, but the Ariane in the Ariane version of the ballistics phase, there's no power. Tonight we have power.
Yes, AVUM, it's a reignitable engine, and he has also its attitude and control. It has its control system. You know, we have the principle is the same in Ariane 5 on Vega, but we don't choose the same gases. On Ariane 5 we use the gaseous hydrogen to use for the thruster, and here on Vega for the AVUM we use only hydrazine propelled system.
All right, we are out of the fourth AVUM stage burn. We have about 2 minutes before separation of VinRedSat. I think we have time for the quiz question. Then I'll ask you a little bit about your job. You want to go to the quiz question? You ready for this?
Yeah.
All right. See if anybody can get this. Let's play along. If you win, you get a big prize. Concerns the new leadership at Arianespace.
Yes.
Very timely. All right. Are you ready out there? See if anyone can get this. It's not really that hard. Arianespace quiz question for Vega flight number 2. How many people have been at the head of Arianespace? There haven't been that many.
No.
Question again. Tonight's quiz question for Vega second flight. How many people, men or women, have been at the helm of Arianespace since the company's inception in 1980, and who are they? Think you have an idea of the answer?
I've got a clue.
You've got a clue. Hold on to it. If you do, we will give you the answer in just a minute. But for now, as we're coming up on VinRedSat separation in under a minute. Again, a moment of concentration and focusing here, even though Proba V was successfully delivered almost an hour ago now. And many here in Jupiter, including yourself, Enrico, you've been in this sort of situation before, I would say even many times. You've lived through this sort of situation. How would you describe the atmosphere down there with the technical people?
Yes, everybody is very focused on the success of the mission, so every technician and engineer is focused that on every system is working well and ready to correct something that is not working as well or normally.
So, all eyes and ears waiting. We should have confirmation in just a few short seconds of separation of our second passenger for Vietnam.
Séparation VNREDSAT 1.
There we are, right on time. You see, pushed away again by the system. And you can hear the applause.
La trajectoire est normale.
Everything is normal. VNREDSAT 1's launch comes 1 month after the official announcement in Hanoi of this year, 2013, as the Franco-Vietnamese year. Now, Enrico, give us the descriptions, as you did for Proba V, of what's going to happen now that she's separated.
Yes, but before that, I want to say that anyway, the TENS this evening will continue until the end of the mission, until the orbitation of the Avrum.
Yes.
And not only after the release of the different satellites. So let's come back to the LEOP of VNREDSAT. The spacecraft will deploy its sun panel about 1 hour after the separation, and it will be switched into a sun acquisition mode. You know, once the power generation is okay, the transmitter will be powered on, and then when it will fly over the station of Kiruna, we'll see.
That's in Sweden.
Yes, exactly, and we will see that about 3 hours and a half after the separation. And the day after, the spacecraft will be switched on the normal mode, and all the payload will be powered on. For the following week, the correction maneuver will get the perfect altitude and orbit for the operational activities.
In just a minute, we'll have separation of SQ1. You can see that. That's the tiny little white square on top of what's left of the Vega launcher.
Yeah.
On top of the fourth stage there, weighing 1.3 kilos.
Yes.
Project began, it's a little one. Project began in 2008. SQ1 developed with the Finnish Meteorological Institute and with the German Space Center, the DLR. Finland, we are told, invented the propulsion system of using electrically charged particles emanating from the sun, which is what SQ1 is going to study. It'll be the first proof of this concept. CubeSats on the first Vega flight last year were the first CubeSats ever to be launched on a European launcher, of course. Vega's first flight launched CubeSats from Italy, France, Spain, Romania, Poland, and Hungary. Romania, Hungary, and Poland were the first satellites ever launched for those countries, like Estonia tonight. And the CubeSats from Spain, France, and Italy, there was one from Spain and two from Italy, were the first CubeSats from those countries. Tonight, of course, Estonia, waiting for separation of our final passenger, I would say in about 30 seconds. The CubeSats, interesting because CubeSats for a long time they were very popular in the US and Japan, but not really active in Europe. So Vega was seen as a chance to give Europe an opportunity to catch up.
I think it's a good choice because it allows us to fulfill some very good education objective for university student.
Get them involved in space affairs, conceiving their own project, building it, led, of course, overseen by ESA.
Yes, and they understand what means develop and test a new technology, some things that after is being built.
So hundreds of students in all involved in these projects. We're waiting for confirmation.
Séparation is Cube 1.
And we just had it.
Yeah. That's a great success. I'm happy for all this client.
There's the final good news and a lot of applause. Vega delivering her third passenger. Cigars and champagne will be forthcoming as Vega performing flawlessly.
La trajectoire est normale.
S-Cube will unfurl a 10-meter single-strand E-sail. There's some happy people there, or tether, testing, as we mentioned, their new propulsion system. In 5 minutes, the power will be up. They'll have their preliminary system checks on the satellite. In half an hour, the radio antenna will be deployed and communication with Earth can begin. 10 minutes after that, the radio beacon will be activated and we'll have our first message. This is when they will know if the launch has been really successful. In 2 days, the satellite's beacon becomes active to determine the satellite's health. And we get our first camera pictures in about 5 days.
Yeah.
And in about 10 days, beginning of the main mission, which is, of course, tether deployment. The tether will be electrified and measurements will begin. Again, S-Cube-1's mission to experiment for electrical use on future solar sails. And as S-Cube-1 is the first Estonian satellite, the project will be used to put in place the nation's infrastructure for future space projects, as well as to form a generation of space engineers. So you see the smiles, the mood, very buoyant here in Jupiter, all across the Space Center, at all the points and posts where the people are working or following the launcher and their satellites. This is the ELV group. Your compatriots?
Yes, all Italian.
Prime contractor of Vega?
Yes, from Colleferro.
Work is just beginning or will soon be at the different ground stations and the centers around the world where the satellite's first maneuvers are being monitored. We're waiting for the speeches. We'll be hearing from Stéphane Israël and Jean-Yves Le Gall and some others. Did you get to answer the quiz question while we're waiting for the gentlemen to come out? Answer the quiz question. How many people have led Arianespace?
I think that if you consider also Stéphane Israël, there are 5 people.
You sure about that answer?
Yeah.
5. That's your final answer.
Yes.
You're right. Congratulations. 5 people. Can you name them? Frédéric Dall'Est, the founder.
Yes, it's the first one.
Charles Bigot, Jean-Marie Louton, who came from ESA, Jean-Yves Le Gall, and Stéphane Israël. Well, congratulations. If you got the right answer, give yourselves a round of applause. And Enrico will send you his check for €2, since this is the second Vega flight. €2. All right, well done. We're waiting for the post-launch speeches. We'll be hearing from ESA, Antonio Fabrizi. The gentlemen will be shortly making their way out to the fishbowl. I see Mr. Fabrizi at the podium. He looks like he's ready. The next voice you will hear will be Antonio Fabrizi.
Can you hear?
Of ESA.
So, dear guests, colleagues, ladies and gentlemen, here at the Jupiter, in the center of Kourou, but also at ESA Redu Center in Belgium, where I understand that the Minister Courant and other guests are gathered for a second chance to witness the launch tonight. So they have been waiting till now. So beside the satisfaction for what we have all seen, tonight I have also the honor to represent here my boss, the ESA Director General, Jean-Jacques Dordain, who regretfully could not remain with us after postponement of the launch. He left me a page handwritten regarding Vega that would have been his speech last Friday if we were not delayed by the altitude winds. He would have done this in Italian, and I had prepared a translation for him, but I will do it in French to be sure that I keep his spirit. Et un et deux, les 2 premiers lancements d'un nouveau lanceur russie, c'est un exploit historique jamais réalisé en Europe jusqu'ici. Vega entre dans l'histoire aujourd'hui après une mission particulièrement complexe. Des lancements réussis ne font pas encore le printemps, mais c'est un bon début, une base solide pour construire un bel avenir pour Vega. Le carnet de commandes de Vega lui garantit déjà 3 ans d'exploitation avec le lancement Verta, qui embarquent des missions de l'ESA, telles que l'AXV, l'ESA Pathfinder et Eolus, ainsi que des missions commerciales comme les 2 satellites Sentinelle de Copernicus et le satellite kazakh. Reste maintenant à l'industrie de produire et à Arianespace d'y exploiter. Vous avez un bon produit, made in ESA, faites profiter le monde. Also, these were the words of Jean-Jacques Dordain. But now, let me express also some personal feelings. And my first thought goes to the ESA member states, of course, to the Vega and Verta program participants, primarily Italy, that with their patience and continuous support have allowed this. And also to the participants to the PROBA-V program, primarily Belgium. Second, I want to dedicate my thinking to CNES CSG for keeping this launch base available to us in spite sometimes of adverse natural conditions, providing support day and night during working days, holidays with great commitment. Thank you. Third, the Arianespace team that has inaugurated the commercial exploitation of Vega with WinRedSat and that managed with reassuring experience the operations in Kourou. Number 4, industry. They have built a beautiful product that works perfectly, provides excellent performance, and allows to look ahead with confidence to the future. 5, my team, the ESA team, all the launchers and also the PROBA team, for transforming my team and my dreams, and not only my dreams, but those of ESA, to transform them into reality with competence and passion. And I think these are the characteristics of all our teams. I do not make names, but I have to make one exception for Michel Courtois, who together with the reviewers, with experience and dedication, give confidence to my team. And I know that Jean-Jacques Dordain agrees on me to mention this. I think that with our member states and with all these teams that I mentioned, ideally, as a unique team, we have a solid base to build the future of European launchers. Finally, 2 words on the satellite, because this is an ESA mission with the satellite of ESA on board, and I wish to thank also the PROBA participants, the team of the technical directorate of ESA, and the industry that has built this satellite for the confidence that they have given to Vega, and for developing a satellite that will provide valuable service to Europe. Now, the complete success must be confirmed by the commissioning of the satellite, but already now we can say that the satellite is in good shape, in a perfect orbit, and I think it will have a brilliant future. Last but not least, I'm glad that, like on the occasion of the first Vega launch, we have given the opportunity to a European state, in this case Estonia, to put also its first satellite into orbit. Et bien sûr, merci à tous ceux qui ont été présents ici ce soir et ont partagé avec nous ces moments. Merci. Stéphane Israël, le PDG d'Arianespace.
Ladies and gentlemen, dear customers, dear colleagues, it's late in Kourou, or maybe early in the morning, so you will allow me to say a few words in French. It will be easier for me to express my great satisfaction after this successful launch. C'est avec beaucoup d'émotion que je prends ce soir la parole pour la première fois en tant que président directeur général d'Arianespace. Comme vous le voyez, avec la réussite exemplaire de Vega, Arianespace poursuit les succès
Arianespace continues its path of successful launches on which my predecessor, Jean-Yves Le Gall, placed it for over 10 years.
L'aventure continue.
The adventure continues. This launch confirms Vega's systems a little over a year after her maiden voyage from the Guyana Space Center here last February. I'd like to thank
ELV,
ELV, Avio, and all the industrial partners who participated in building the launcher, which is today 100% operational, ready to offer the best service to our customers. With 3 operational launchers here at the space base, Arianespace is the only launch services operator capable of putting all types of satellites into all types of orbits. This launch also confirms a success for Europe and shows that the continent can meet a long-term challenge. I'm sure that today's newest success of Vega, which is fruit of a long collective effort, points to a bright future for our new common European projects. I'd like to warmly thank the European Space Agency, the Italian Space Agency, the French National Space Agency, and all the member states that helped finance and develop Vega in the VERTA program.
Comme l'a rappelé M. Fabrizi, par l'Italie, qui est le premier contributeur.
And I'd like to start with Italy because you all know.
Je suis heureux de m'associer à la joie de Jean-Jacques Dordain, dont nous avons.
I'm pleased to share the happiness felt by Jean-Jacques Dordain, ESA's Director General, and by Antonio Fabrizi, ESA's Director of Launchers, to whom we owe so much, going back to the very beginnings of this project. To both men, I say bravo for your determination and many thanks. Passengers tonight link Arianespace to missions that serve the Earth and sustainable development. I underscore this important point, which is in the heart of all European Union citizens, because it shows that while technical ambitions involved in our space efforts are constantly being reviewed and renewed, space also serves the general interest.
Que ces missions et cette ambition technologique sont d'abord au service de l'intérêt général et des citoyens. Je veux me tourner naturellement vers nos
turn to our
clients,
customers, without whom our launches would have no reason for being. You placed your trust in Arianespace and in Vega, and you did the right thing. I predict many others will follow in your footsteps. Thanks again to ESA, this time for the satellites, Proba V and S-Cube-1. Thanks to Belgium and to Mr. Philippe Courard, the Belgian Secretary of State for Scientific Policy, for their ongoing commitment to space. We've seen this commitment through Belgium's contribution to Vega and with the Proba V satellite. Thanks also to Estonia and to Madame Ene Ergma, President of the Estonian Parliament, for their commitment to this Vega mission through their satellite S-Cube-1, the first satellite orbited for Estonia. Thanks to our long-standing partner Astrium and to Vietnam's Academy of Science and Technology for this fine project, which is VinRedSat-1. What better way for Arianespace to honor this Franco-Vietnamese year than by launching this third satellite for the nation? After 2 telecommunication satellites, I'd like to thank Mr. Chow Van Minh, President of the Vietnamese Academy of Science and Technology, for his trust, as well as for his Vice President, Mr. Din Cong Nguyen, and the entire Vietnamese delegation, which was here with us in Kourou. And hello to Hanoi, where you're watching this evening, or should I say this morning. Finally, and on a more personal note, for my first launch as Chairman and CEO of Arianespace, I'd like to say a few words to all the men and women in Europe and in French Guiana who develop, produce, and build our launchers, and especially to the men and women of Arianespace. I appreciate the force of your commitment and your professionalism. Through all of you, I'd like to pay tribute to what I like to call the entire European space ecosystem, the states which finance space policy, the agencies who conceive and develop the missions, the space industry, which is always at the cutting edge of world excellence. Without this active community, which is both public and private, driven by states and coordinated on a European-wide scale, Arianespace would not be able to offer its customers the level of high-quality service that we've come to know. Our customers are our raison d'être, and I'd like to give them the floor now. Thank you.
Dear colleagues, dear all, I will make the speech in English for our Vietnamese community. It was important, it was a challenge, and you made it, we made it, and I would like to, on behalf of Astrium, to congratulate all the people, all men and women, who have participated and allowed this big success. Astrium do recognize the level of this challenge. It was a second flight of a new launcher, and it is a success. It was a complex mission, and with multiple payload configuration. It was the finalization, the tuning of a qualification of a launcher system, and it was a transition to its commercial life. So, thank you for all. Thank you first to the VAST, the Vietnam Academy of Science and Technology. Thank you to the Vietnam government for the trust awarded to Astrium and Arianespace to select the Vega launcher. Thank you to Arianespace and ESA for this smooth ride to orbit for VNREDSat-1. Thank you to CNES for global support in CSG and for its partnership, in particular on Myriad for this program. Thank you to the French authorities represented by the Ministry of Finance and whose representatives in Paris and Hanoi have allowed the financial engineering of this program. The last but not least, of course, is thank you to all Astrium teams and all industrial teams for their efficiency and sometimes for necessary patience they had. This success shows the way for the next one, which is the third flight of Vega, on which Astrium has already put a satellite, a new commercial satellite. Astrium is always looking for more challenges and progress and innovation. Thanks again to all the community of professionals who has worked hard for this achievement. I wish a very good start to VNREDSat-1 satellite, of course, whose first signals will be catched by the VAST team and Astrium team in the coming hours. I wish also a good start for our payload partners during this launch campaign. That means ProbaV and IceCube. And in conclusion, I would like to say for the Vietnamese that we are very proud to participate at the anniversary, the 40th anniversary of the exchanges between France and Vietnam. And this event is a big event for that, and we are very proud of that. Thank you.
Bien, je voudrais à mon tour, en dépit de l'heure tardive ou matinale, comme vous voudrez, dire quelques mots. Donc ce lancement est le premier effectué depuis que j'ai changé de casquette, mais vous le savez, j'ai de multiples casquettes. Donc depuis que j'ai été nommé président du CNES le 3 avril, et je suis particulièrement heureux. Heureux d'abord parce que ce deuxième succès de Vega est un succès de plus à mettre à l'actif des équipes de l'Agence spatiale européenne, d'Arianespace, de l'industrie et bien sûr du CNES, le Centre spatial guyanais à la direction des lanceurs, qui ont une nouvelle fois démontré qu'elles savent travailler ensemble. Et vous faites le bonheur de nos clients qui, à l'évidence, ont l'air ravis. Si j'en juge, je crois que ce sont nos amis italiens tout à l'heure qui l'ont démontré de façon très visible. Heureux aussi parce qu'avec Ariane 5 qui fait la course en tête des lanceurs lourds, avec Soyouz qui a déjà 4 lancements à son actif au Centre spatial guyanais, et maintenant avec Vega qui est définitivement et pleinement opérationnel, nous avons la capacité de lancer tous les types de satellites vers toutes les orbites. Et je peux vous dire que cela va nous être particulièrement précieux pour notre plan de charge dans les années à venir. Et heureux également parce que le parfait fonctionnement de Vega démontre la maîtrise des solutions innovantes utilisées sur ce lanceur, en particulier pour le premier étage à propergol solide P80, solutions qui seront à la base du développement de la prochaine génération des lanceurs européens. Et vous le voyez, nous préparons déjà la relève. Alors je voudrais féliciter tous ceux, et ils sont très nombreux, auxquels nous devons ce nouveau succès, en Europe et en particulier en Italie. Et là, je vais vous demander d'applaudir, parce qu'il faut applaudir pour Frascati, il faut applaudir pour Colleferro, il faut applaudir pour le boulevard ou l'avenue, je ne sais pas, Doménil. Et puis bien sûr, il faut aussi applaudir pour Évry. Et en Guyane, je crois qu'il faut aussi remercier toutes les équipes qui ont été impliquées dans la campagne de lancement et qui ont fait un travail remarquable. Et puis, il faut aussi dire bravo aux spécialistes de la météo. Grâce à eux, nous avons pu enfin décoller ce soir. Et puis, grâce à eux, et c'est peut-être le plus important, on va dire que dorénavant, le CNES fait la pluie et le beau temps. Merci et à bientôt. Bonsoir.
Bien, donc pour conclure cette soirée, donc au-delà des remerciements renouvelés, juste pour vous dire que s'agissant de Vega, donc deux lancements sont prévus l'année prochaine, notamment DZZ HR avec Astrium et le Kazakhstan. Et ici au CSG, nous nous retrouverons le 5 juin, à nouveau en compagnie de l'ESA, pour le lancement d'une Ariane 5 modèle ES avec à son bord le quatrième cargo ATV nommé Albert Einstein.
The fourth ATV cargo vessel called Albert Einstein.
Ce lancement ne peut être qu'ingénieux et particulièrement réussi. Puis ensuite, nous retrouverons fin juin pour les satellites O3B. Je suis allé les voir aujourd'hui. Donc les 4 sont en cours de
another launch with Soyuz of O3B, and then later in July on Ariane
AlphaSat et Insat 3.
5 Flight 214
voilà, donc rendez-vous le 5 juin pour la
see you again on June 5th. I wish you all a very pleasant good evening. All right, we're over those pleasant words. We're going to have a last launch replay and say goodbye. Any last words?
I would like to congratulate all this big team made of launcher people and satellite people.
I think that's
Bravissimi.
enough. I think that's enough. Congratulations to everybody. The next launch, another milestone, as you heard Stefan Israel say, the fourth ATV bringing supplies to the International Space Station on June 5th. We'll be here. We hope you will be too. Until then, on behalf of everybody here at the space station, Joshua Jampa with my friend Enrico Postamai of ESA, saying thanks for being with us. We'll see you next time.
Ciao.
Bye.